Assalamualaikum and good day everyone. Today, I'm going to present you about coordination chemistry. Coordination chemistry is the study of compounds where a metal ions is bonded to surrounding molecules or ions called ligands. These ligands donate electron pairs to the metal, forming a coordination complex. Me and my partner has chosen this article for us to review. In this complex, the metal ion used is manganese in the oxidation state +1. There are several ligands that can be found in this complex. First one is carbonyl, and the second one is halides. The halides can be chloride, bromide, or thiocyanate. And the last one, which is the main ligand, is 1H, benzimidazole, 2-methyl, and phenyl amine. This is the chemical structure of the complex. And now, let's move to the chemical structure of ligands. The first one is carbonyl, and then the second one is halides, and the last one is the 1H, benzimidazole, 2-methyl, and phenyl amine. For the main ligands, I will show you how it will look like in 3D. Now, let us look at the classes of ligands. For carbonyl, it is monodentate, while for halides, such as chlorides, bromides, and thiocyanate, all of them are also monodentate. However, for the main ligand, it is a bidentate. Next, let us move on to the characterization methods of this complex. The first method is IR, infrared spectroscopy. This method is used to detect carbonyl ligands. Next, the second method is NMR, which we call as nuclear magnetic resonance spectroscopy. Through this method, we can identify the ligand structure. The third method used is UV visible spectroscopy, or we call it as UVVs. This method measures electronic transition. It shows metal to ligand charge transfer, which is MLCT bands.
Here is a step-by-step synthesis of manganese tricarbonyl complex. Before that, we need the starting material, which are manganese precursor, ligand L, solvent which is ethanol, and salt for ligand exchange. Step 1 is preparation of reaction mixture. Dissolve the manganese precursor in ethanol under stirring. After that, add ligand slowly into the solution. This will form the initial coordination mixture. Step 2 is called reflux reaction. Heat the mixture under reflux condition, which is from 60 to 80 degrees Celsius, and continue stirring for several hours, typically 3 to 6 hours. This step is for replace 1CO ligand and allow bidentate ligand to coordinate to mangan. The formation of intermediate complex, which is manganese precursor with bromine as a ligand. This color will usually change to yellowish or oranges. The next step is ligand exchange for halide substitution. Add any salt with ion that we want it to be the ligands. For example, if we want chlorine to be the ligand, add potassium chloride, and for NCS, add potassium thiocyanate. Then stir at room temperature or mid heating. Step 5, which is isolation of product. Cool the reaction mixture, filter the precipitate solid, and wash the cold solvent with ethanol. Lastly is purification. Dry the solvent under vacuum, and optional, recrystallize from suitable solvent so that we will obtain the pure crystalline complex. The synthesis involves ligand substitution and coordination under reflux condition, followed by halide exchange to obtain different complexes. The application of these complexes: first, control carbon monoxide release. These complexes act as carbon monoxide releasing molecules. They release carbon monoxide when exposed to light. Why is it important? Because carbon dioxide in small amount can act as a signaling molecule in the body. Second one, potential biomedical use as anti-cancer. The complexes showed cytotoxicity against leukemia cells. This means that they can kill cancer cells effectively. The third one is reactive oxygen species, ROS generation. Light exposure increase ROS production, so this is especially strong in the bromide complex. The fourth one is interaction with biomolecules. Complexes interact with DNA, protein such as lysosome and myoglobin, and amino acid. This will affect to biomolecule influence, which is carbon monoxide release behavior, help in enzyme targeting during drug delivery system. And the last one is photoactivated drug system. This is because it will activate by specific wavelength. For example, is 365 to 466 nanometer. The advantages is drug can be controlled using light, reduce side effect on healthy cell. And I want to tell you that this only the chloride complex showed toxicity to normal cells, meaning is the other complexes may be more selective and safer.